figure this out. Yeah, okay, we're good. Start the recording. I'm going to open up a Python thing. I'm going to do file. And let's just talk about the final, right? So the final's right here. Final lab, get the PDF or document, look at it. You need to write a trivia game. Have a welcoming screen. Now here's, if you look at, let's just download this real quick, open it. Boop, boop, boop. Here's the requirements right here, right? Bloop, bloop, bloop. Copy. Paste. Good, right? Here's what I need. Now, let's rip through this. Well, what's the first thing we need to do? Pseudocode. Welcome instructions. Doesn't matter if it's spelled right or not. This is just me pseudocoding. I need to welcome instructions. Then I need to get user input. Get user input if they want to play. Play. Then game. Then play again. Then end. Right? Cut and dry. Well, now you start to get into the design phase of where you're, okay, well, am I going to do anything with random? I might. Import random. What else am I going to import? I don't know. I'll import time for fun for now. I might need it. Right? Well, I need a welcome. Okay, cool. Define welcome. Pass, right? For now. After that, you're like, okay, cool. Well, you know what I really need to do? I need to define main too. And the first thing in my main is going to be my welcome. Then I'll go down here and I'll be like, print F, welcome to the game, whatever, right, for now. Cool. So that's already done. Then you design your game however you want, question and answer. What's a question and answer? Key value pair in a list. Sounds like a dictionary or a list. One of the two, right? Can you create a dictionary like this? Test equals dictionary. And then call on test. Remember I add stuff? Q1. Then equals. And then can you do a list? I don't know. Let's test it out. Oh, syntax error. What'd I do?
You put the wrong parentheses, didn't you?
Yeah. My bad. It happens to the best of us. All right. So now let's add this to this. Cool. So when I call on test, you can put a list. So your question could literally be a question, and your answers could be a list of 1, 2, 3, 4, and 5, or 1, 2, 3, and 4. You can say question 1. You can even design this. Okay, now listen to this. Have 5 items. Now, this is one way to do it, but there's 10,000 ways to do this, right? Let's just say you have 5 items in here, right? Q1, when you call on Q1, you can call on Q1 value into C1, and this could be your actual question. Then this could be answer 1, answer 2, answer 3, answer 4. And then literally it could be like, how much does the moon weigh? 1 pound, no pounds, what moon? 1 billion. And then this could be the indice number of your correct answer. So let's say number 2A was the correct answer. So from a single entry in a dictionary, you could have this is the key, Q1 is the key, This is the how much does the moon weigh? This is nothing, 3 pounds, 10 pounds, 40 pounds. Indice 2 of this list is the answer. You can design it however you want. Or you can use a list of lists, which is nothing more than a cheap dictionary. So you could say, like, my list equals, then you could throw in, like, that's better yet, Q1. Q1 equals, what is the moon weight? And then you could say 10, 100, or whatever, 2. You could do whatever you want. See what I'm saying? And then you could literally call on, when you go to answer, like, ask someone the question, you can just do Q1 slice 0, and you get your question, what is the moon? Then you can call on all the other values. You can call on the indices 1 to the end, give them their selection, A, B, C, D, E, have them select it, and then have the right one somewhere else in a different, you could have a second list called answers and have the answer duplicated in your question and in your answer list. What do you think of that?
Yeah. Wait, how do you call them?
Yeah.
Answers.
The answers, you could do something like this. Q1, start at 1, and go to the end. Now that gives you a list back, right?
Mm.
So you could literally do this. Say this is your potential answers for question 1. Potential answers for question 1 equals Q1 1 colon to the end, right? And now you have a list, right? Potential answers Q1. I have a list. And now I can say, after I presented my question, I can say for each answer in potential answers Q1, print answer. So now I can also dress this up, put an A in front of it, and then, or a 1 plus 2 plus 3, so they could answer back 1, 2, or 3, or type the whole answer. See what I'm saying?
Yeah.
Like, you could really design this a million different ways, because you could seriously do an F string, quote this, and go. Do you have to do that? I don't think we even need that. We could do answer. We could add a counter up here and then add the counter to this, and then have the counter iterate right above this. It would need to be out of the loop though, so it adds 1. So you need to define your counter first, and then have it loop and add 1 to your counter, so it prints out like print or we'll just do it here. Let's do this. I'll do counter equals 0 and 4 answer and just 1 crazy. I'm just thinking off the top of my head, riffing, man, having fun with this. And you could do counter equals plus 1, and then you'll say print F string quote counter quote period quote, and then curly braces, and then answer curly braces close quote. Syntax error. What did I do? I'm gonna get this now. I don't think we need these. There. Now, if I add define counter first, did I? Dang it. Counter equals 0, counter equals plus 1. Oh man, counter plus 1. I didn't do counter equals plus counter plus 1. So I missed counter plus 1 and right here, right? So it goes up by 1. My bad. But you see where I'm going with this, right? It'll say 1, 2, and 3, and then
Yeah.
then underneath it you could say what's your input, and the user could put 2. They could put if user picked 2, is 2 correct? And in a dictionary or another list or something, you could literally have 2. You see what I'm saying? And then compare it to the answer. Like if this was question 1, which is an index 0, you'd have another list called answers, and it would equal a list. And if this answer was 2, you'd put 2, comma, next answer's 3, next answer's 1, next answer's 2. Like if question 1, which is indices 0, then you can say if answer indice 2 or answer indices 0 equals 2, they got it right. If not, you got it wrong. See what I'm saying?
Yeah.
Yeah, you can do all kinds of twisted stuff like that. Like I like the dictionary method because it's a little cleaner and faster, and you can do it all in like a couple dictionaries or one dictionary. Like each, you could do. We could do a lot of things. You could do like all your questions or your keys. You could do that. Keys with the lists of answers. You could do a Q1. You could make 4 different dictionaries with your, like 4 different questions. There's so many different ways you could do it up until now. You could write all your questions and answers in a file, much like we did with the World Series winners. Import that file, create dictionaries from a file, play your game that way, create another list on how many times you want it, and print it out. You know, you can really flex here. How good and how much time you put into this final will replicate if you save it to a GitHub and put fundamentals of Python in your resume, then you can point them to your GitHub on what you know how to do. That's kind of a win-win.
Yeah.
Right? So there's a million ways to do this. I would put the next 2 weeks, I'd put some good time and effort into this. I know it's only 30 points. I know you need to turn it into to complete the class. Here's the deal. This one script, really well done, could go on your GitHub or on your LinkedIn or a screenshot of it and be part of your resume and potentially separate you from somebody else. So how much effort you put into this is how much effort you put into it. See what I'm saying?
I see what you're saying.
Sure, right.
Yeah.
Makes sense.
And, you know, and GitHubbing a script that you do in school, I'm cool with it. You know, it's real programmers get paid and they don't post their code. Yeah, you heard me. Like open source is awesome. Open source is a good start. But real programmers deserve to get paid. That's all I'm saying. That's all. They don't give their stuff away. They don't give the best stuff away for free, right? And if they do, then you're the product, not their code. But you know that's one way of doing it. But then you could just incorporate that in here. Got your welcome, got your game done. Do you want to play again? Copy that from your lesson 5 script. Boom, you're done. Throw it in main. If name is equal to main, you're in business. Fire main. And as you build your code, you know, okay, got my welcome done. I'm going to call on my game next. When my game's done, I'm going to call on the ending or play again. Play again, and then play again might call on end. You know, if you do play again, and if they answer no, then you can call on end and play again. So this may be all you need. Depends on how you decide. You know, really design your script. And right here, only place I need try. I mean, not you could do more. You know, it never hurts. Accept whatever you want to accept, and then you know whatever you want to do here. I'll just do that for now. But you know, you can accept whatever errors you get from here, and then print about them. But this is it. Like this is a decent starting construct, you know. And what would this achieve? Well, mainline logic is good because you got your main and your mainline logic down here, mainline validation. You got your error handling, try accept. Got your header, you fill in your header. Got your comments, you'll make a comment. Yeah, we got comments. We pseudocoded our comments. That's good enough. Global local variables, they're going to be all over the place after you build all this stuff. At least one custom function. Well, I got 3, 4, counting main, right? One tuple list or dictionary. All my questions are going to be lists or dictionaries. I'm done. And one looping function. Well, for each question in my answers or each question in my question. Done. Right? This right here is a majority of what great scripts start with. Most of them you're doing, hey, is this machine online? Okay, if it's online, can I access it? If I can access it, can I check to see if this patch is there? If it's not there, install it. You can write a script that does that for 10,000 different devices and let it rip all at once. You can do all kinds of really simplistic stuff. And you don't necessarily need Python for that. You know, you could do Bash or whatever, but I'm just using it as an example, right? There are a couple Bash in Python using subprocess. You know, that's something that we could spend another hour for, but that's like intermediate Python, right? You're not done just because you've passed the fundamentals of Python class. That's one thing I want you to know, because you guys want to go over a couple things that you'll see out in the wild.
Yeah.
Okay. One is enumerate. So the actual command is enumerate. Let's talk about a list. List 1 equals, I don't know, I'll put a couple things in here. Test, Tim, and Steve, right? So we got a couple different items in there, right? In my list 1. You can go for each item in L1, print item. Right, and let's say L8, that's good enough. And when I hit F5, you'll see those items, right? Well, there's another way to do it. You could say, let's see if I remember this right. For item in enumerate, enum. I love this, that spelling. Enumerate. So see how it's purple? Enumerate is a function. So for each item in enumerate, then you're going to tell it the object you're going to look at, which is L1. And then you could start at 0. You can start at any indice you want. That's start. You see how it says start there? The second parameter of enumerate is where you want to start. The default is set to 0. So I really don't need anything. I can just do this. Well, what do I want to do for each item in enumerate starting at 1? Well, I could just print item. And you're going to go, well, what's the difference? Well, you get the indice of it and the object. And there's ways to cut off the object, and there's ways to cut off the count and all this fun stuff. But let's see. Print count printer. So
That's
you could
kinda nice
also
how it tells you the position.
Yeah, well, you could do things like item, you could do count. I gotta spell right. Count item. So now you have 2 variables for each count and item in my list. Print the item only, right? Save F5. Well, now I just get my item. Well, what if I wanted to print the count? Well, count. And now I get the indice. So now I can print the count and print the item. Enumerate is more of what's called a mapping function. So what it does is it maps the object to its indice. Kind of a no-brainer, right? But you're going to see enumerate out there in more complex and more complex things. And the neat thing about enumerate is there's something called next. So let's just say, let's just call this item 2, right? And I say item 2 is going to equal enumerate. And now I'm going to call on my list. But I'm going to wrap this in other things and say next. And then I'm going to print item 2. So did that work? No. Next. Well, I never printed anything, right? I never got the first item. So my item is really the first indice, which is test, which makes sense because if I never got an item before, it is the next item. It's the very first item. Well, let me think how to use this in a loop. You can keep on calling on next somehow. I can't remember. It's avoiding me right now. Let's do this. Boop, boop. Yeah, it's going to fail back. Because see what L1 is. L1 grabs your list, creates a tuple of it, and then next is like, yo, I don't know what to do. I can't iterate through a tuple. So it kind of saves you. But next is out there too. I don't very use it that often, obviously. I'm pretty rusty with it. You can sell that right now. But it's one of those things you're going to see out there in intermediate Python. Now, some of you are going to be kind of mad at me for this next one. It's called a lambda function. Lambda functions are small, compact functions that are really good at doing something. And the syntax of them is literally lambda, and then arguments, like you give it arguments like you're writing a function, and then the expression all in one line. So what would this look like if we want to do something? Let me think of something. Let's do this. Let's say output equals empty variable. I'm going to call lambda. You notice how it's yellow, so it's an operator, right? It's a function. It's going to do something. I'm going to say lambda. Now I'm going to give it variables, a comma b comma c, which are their arguments. When you write a function, you have the parentheses and you put your arguments in there, right? I'm saying lambda function, my arguments are a, b, and c. I'm going to separate my arguments and my function from my expression. My expression is just going to be a plus b plus c. So if I call on output and give it 3 arguments, it should add them together and just print them out to the screen. So now I'm going to say print, and now I'm going to call on output, and now I'm going to give it my 3 variables. So I'm going to give it 10, comma 4, or 5, comma 4. So this should print out 19, right? Save it. Let me get rid of all this up here. Don't need the other one anymore. I'll comment it out. And we get 19. So instead of writing a whole function that would look like this, define addition or output, define output, and then go in x comma y comma z equals, then you put var1 equals x plus y plus z, return var1. This is the same as this. Pretty cool. Sort of cool. Not really that cool.
That's pretty cool. It's a lot easier.
Well,
Yeah.
there's
Lot less.
there's something pretty cool about lambdas though. You could use these inside of a function. So if you have a crazy function that does a lot of hardcore stuff and you need to do some quick math in your function, you don't need to build another math function. You could right here call on a lambda, put this right in here. And then name this output 2. It can't be the same name, right? So output 2, X, Y, and Z, output equals lambda. So X, Y, and Z here, X, Y, and Z, you gotta just make sure it's all the same. I'll just ABC these. So now you're gonna feed output to ABC. Lambda's gonna use your ABC, add it together, and throw it in output. Now, you don't have to stop here. Like if you needed to divide it or get an average or like do a stat file, something like you can keep going your function doing crazy stuff, but you just needed these 3 things added really quickly. You could just say lambda, add these things, output. You see what I'm saying? Like you don't need to create a whole other function and call on it from inside a function. You can just really quickly make a function that'll fire over and over and over the same way in one line. And they get pretty tricky, but when you see the word lambda, instantly know that anything up to the colon is parameters or arguments, and then after the colon is the expression. That's all you need to know. And then you're going to see some really complex ones out in the real world, but after you break it down to what it really is, just call it on lambda. These are just arguments. They're just variables being passed to whatever's on the other side of the colon. That's it. Nothing fancy, nothing tricky. Don't be afraid of them. Super helpful, right? Insanely helpful. What else do I have? I've got kinds of silly notes over here. Okay, list comprehensions. Some people already try to use them. And what a list comprehension is, it's a list, it's a variable that equals an expression for an item in an iterable condition if it is equal to true. So what is that really saying? It'll return the value in a new list, leaving the old list unchanged. Okay. Let's just do it, right? Blah, 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 blah. Let me see if I got a good example here. Let me open that. I think I do over here. Let me find it. And you'll be like, oh, that's how it works. And you'll be like, yeah. Lambda with inner function. Of course, I don't have it. Dang it. So now I'm going to have to go out and write it. Thought I sent myself one. Let me take one more look really quick. Extra. I will do one in a second, but we're going to pivot here really quickly. What are cool thing you do? So you can make directories with the OS module and system module and subprocess. That's cool. Let me open. You guys work with Nmap? Any cybersecurity folks? Mess with Nmap in here? Nmap has a
On the
Python.
lab.
Yeah. So it's like a big GUI that you like click through and you set up your target and your host, your list, all that stuff, right? Select your port ranges, all that stuff. Well, Nmap comes with when you install Nmap, it has a Python module. So you could go import Nmap, and here's your target by using system, right? This is argument variable number 1, which is I'll show you in a second. And then ports, I just give it a list of ports, right? 21, 22, 53, 80, common ports you'll see in a Windows machine or most machines, 80, 443, 80 internet, right? 139 is what? Anybody know what that is for Windows? And you go, okay, cool. You call on nmap.port scanner. And I save it in a variable called scanv. It gets kind of wild because you'd have to type nmap.portscanner dot something every time you want to do something. So I just throw another variable to shorten it up. And you literally ask the user, hey, what target do you want if you didn't type in a variable? And it'll say for each port and ports, port scan equals scan V. So you're saying nmap.portscanner scan the target string ports, and it'll output this. This is all your design right here. You can say print port scan port, and it'll iterate through your whole port scan, telling you if the ports are open or not on the target that you did. Quick script, down and dirty. You don't have to light up a whole nmap GUI. Kind of cool, right? I think it's cool.
Pretty slick.
Yeah.
Yeah, you can do all kinds of cool stuff with this. nmap.org, you can download the scanner, it's free. You can do all kinds of stuff with it. I just want to show you that because it's really cool. Now let's go list comprehensions. I somehow lost my file, I overwrote it. So we'll just go look at it. List comprehensions I want to bring up because they're in the wild a lot. And they come in handy. And once you start using them, you really don't stop using them. List comprehension right here. Let's go to the Google Docs and go for Geeks. Sometimes they have some good stuff. So more with lists, append this and this, blah 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 blah. Functional programming tools, list comprehensions. So this is right from Python.org. A list comprehension provides a concise way to create a list. Common applications are to make new lists where each element is a result of some operation. So you have some type of for loop, some logic that needs to be put into a list. A list comprehension may be something you need to build, use. Each member of another sequence or iterable, or to create a subsequence of those elements that satisfy a certain condition. Okay, so this is the way we learn in the fundamentals. Build an empty list called squares. For each x in my range stopping at 10, 0 through 9, 10 objects, squares.append, append to my list, x to the power of 2. Okay, so 0 to 2, 1 to 2, 2 to 2, so on and so forth, right? Well, print squares. Here's the same thing as a list comprehension. Squares, the name of the list, the expression you want, x to the power of 2, for each x in my range of 10, and you will get the same exact thing. Let's give this a try. Where's my output? Right here. What happened? Where'd squares go? So there's my squares. It's a little bit more tighter, right? So what did the list comprehension do for me? It created the list for me. It iterated through each item in my range, and it iterated them and put them to the power of 2 all in one line instead of 3. Pretty cool?
That's pretty cool.
Yeah.
You'll see this stuff all over from people who are like intermediate Python or even some like high-end like fundamental Python folks. It saves room, and once you start using them, you just go for each item in my list, which is normal talk, and then you say perform this. Now, list comprehension goes like this. Perform this for each item in my list, and then save it in my list. That's it. Perform this action for each item in my range or list of whatever, and save it in squares. That is the same as writing these 3 things if you say it out loud. Right? Isn't that cool? List comprehensions are super powerful. Where could you have used them in this class? Video's not sponsored by Splunk, but if you want me, that's cool. Hit me up, Splunk. You could use them all over, man. from lesson 5 all the way to the end now. List comprehensions are handy dandy. They make your code really easy to use once you learn what they are. Cool stuff, right? Cool stuff. You're never done. There's always something to learn.
Yeah.
And
I wish I knew this before.
what's up?
I wish I knew this before.
Yeah, but you wouldn't know what they are if you didn't do the for loop first. You know what I mean?
Yeah.
If you yeah,
Good point.
if you didn't go for each item in my items, create this list and append it, you wouldn't know that, oh man, I could just create a list, have an expression, and have it do for each item. It's a little bit of a mind-numbing thing, you know what I mean?
Mm-hmm.
And another cool website, man. If you guys PyPy, this is how many projects are. This is kind of like GitHub for Python, but not really, right? It's sort of. It's they're a bunch of Python packages, exactly what it is. A lot of them have coinciding GitHubs. But if you just type in like cybersecurity or infosec or cybersecurity, you gotta spell it right, security, you're gonna see all this stuff. And SYST framework for meta package, what's that? I don't know. Cybersecurity module, what does that mean? You know, you can go check these out. And Phantom, Shield, Cipher, Python library for cybersecurity, what does that even mean? You know what I mean? But take a look at the dates, see how relevant they are. Sandboxer, 6Python, you know, one of my favorite ones is Scapy. Scapy helps you manipulate packets. It could read packet traces, kind of like Wireshark, except you never have to leave wire. You don't need a GUI. It's kind of like what I showed you in Nmap. It's a Python way, a text-based way of ripping through PCAPs. And not only can it do that, it can also create traffic. So if you want to test an IDS rule, an intrusion detection system rule, you can create packets that look like malware that you're trying to find or some kind of weird packet. And you can literally send that weird packet from A to B with Scapy and then set off your trigger if it passed through the IDS, you know, to test your rules. That's what every good IDS person should be doing, right? But isn't that cool? Can't tell me it's not cool. That's cool.
Yeah, it's pretty cool.
It's super cool. Like a lot of network folks use this, a lot of IDS firewall engineers. It allows you to test, you know, just your rule sets basically to make sure that they're legit. Am I blocking what I'm saying I'm blocking? You know, a lot of bogus malware or something has like some type of indicator or compromise that you could look for in a packet. Then you write up a rule, dump it out, and test it using this. It's super fun, dude. This is pretty cool, but yeah, it's cool. Scapy in 20 minutes. They have all these useful tutorials and fun stuff, but Scapy's pretty good to know, especially if you're getting into cybersecurity and like networking, high-end networking, like well, not even high-end, just like you know, if you like firewalls or IDSs or anything that moves over the wire, Scapy's my favorite package for that stuff, right? But it's never over, right? It just keeps going. But I'll stop the video here.